Page 86. General knowledge of sawing work. Sawing is a method for cutting workpiece using many small saw blades. It is similar as a sharp of chisel grouped together as a row. The saw blades bite workpiece simultaneously until it's torn apart. Pressure on saw frame. Using sawing machine, the more distance from the head of machine, the more pressure on saw blade for cutting workpiece. So to adjust the distance of pressing point, user should observe cutting behavior of saw teeth. Pressure near the head of machine, less pressure on saw frame. Pressure far from the head of machine, more pressure on saw frame. Saw blade. Saw blade is a device of sawing machine for cutting workpiece. Normally, saw blade is made of high-speed steel. It is hard but brittle. In assembling saw blade to saw frame must be done correctly and screw the blade with appropriate tension to prevent breaking the blade. Part of a saw blade includes width, length, thickness, width of saw hole, and number of teeth, such as rough and smooth. The number of teeth will be in number of teeth per inch, such as 10 teeth per inch or 14 teeth per inch. Normally, the number of teeth used generally is 10 teeth per inch. Page 87. Characteristics of the blade. Length of saw blade. Measuring the length of blade will be measured from the center of both holes of blade, that is 200 millimeters and 300 millimeters. Width of saw blade. Width 12.7 millimeters or ½ inch. Thickness of saw blade. Thick 0.64 millimeters or 0.025 inch. Number of saw teeth. Measuring the number of saw teeth can be done by measuring the distance of the top of a tooth to another tooth. In metric system, call pitch. In imperial system, we'll measure the frequency of teeth or the number of teeth per inch. 1. Blade. 2. Thickness. 3. Width. 4. Set curve. 5. Tooth pitch. 6. TPI, tooth per inch. 7. Gullet. 8. Tooth face. 9. Tooth rake angle. Angle of saw teeth. Each tool of saw blade has 3 important angles as follows. Sharpness angle, cutting angle of saw tooth. Hook angle, angle that used to remove scrap metal from saw teeth. Back clearance angle, angle that reduce rubbing against saw teeth and workpiece and create sharpness angle. 3 angles will be added together. Page 88. Select the blade to match the application. Shape of blade. 14. Coarse. Number of teeth per inch. 14. 16. 18. Example of material. Soft material such as aluminum, tin, copper, lead, plastic, alloy steel. Length of cutting. Larger than 40 millimeters. Shape of blade. 22. Medium. Number of teeth per inch. 22. 24. Example of material. Medium to hard material such as cast iron, steel, brass. Length of cutting. Less than 40 millimeters. Shape of blade. 32. Smooth. Number of teeth per inch. 32. Example of material. Hard material such as steel for tools, high-speed steel. Length of cutting. Metal sheet, thin tube. Page 89. Tooth set. Tooth set is the width of groove on the workpiece after cutting. Tooth set is normally thicker than saw blade. Without tooth set while sawing, saw blade will stick with workpiece and cause damage of the blade. Characteristic of tooth set. Straight tooth set. Character of the teeth is alternating left and right along the saw blade. This type of tooth set is suitable for sawing machine. Wave tooth set. Character of this look like wave. This type of tooth set is suitable for handsaw. Raker tooth set. This type of tooth set has both free angle. This type of tooth set is suitable for circular saw. Raker tooth set. Wave tooth set. Straight tooth set. Page 90. Clamping workpiece for sawing work. Wrong clamping of sawing work in case of short workpiece. Cam's clamp will not hold the work tightly. Pressure force from the thread will push the workpiece out. If workers still force sawing, the saw blade will be broken. For correct clamping, two sides of clamp must be pressed in parallel with each other. If short workpiece, supporter can be used to parallel the clamps and screw the tread until workpiece is held tightly. Block of steel. Workpiece. Wrong. Correct. Clamping workpiece for each application. Page 91. Measurement of cutting workpiece and using cut-off gauge. Sawing a number of workpieces, if measurement must be done every time, it will waste time and the size of workpiece maybe varies. To solve this by making the first measurement and then using cut-out gauge to help in sawing the next pieces. Cut-off gauge can be used to measure a lot of workpiece in sawing with the same size. Cut-off gauge can be adjusted by screwing and tighten. After adjusting 2 points of screw must be tightened because when pushing a new workpiece it may crash against the gauge and the set value may be changed. Remember, do not push workpiece too hard. If so, the length of workpiece may be changed.